Hi, Aleph. Just going to help you with this question here. So we've got all this vanadium stuff going on, and it wants to it wants to state the oxidation state of vanadium, right? Or first of all, we have to determine the vanadium species because we've got a few vanadium species in our reduction equations up there. And so we've got to write those two details as well. Okay, so the thing to notice is that there are sequential reactions happening here. So the first one is the one that you spotted, right? So you've spotted the V3, right? So first of all, I suppose you spotted these are in the opposite order to the ones we're more familiar with. Normally, we have the most positive at the top and the most negative at the bottom. Never mind. Okay, so our manganate, which is what we've got excess of here, all right, is our oxidizing agent, and what's being oxidized is this one here, which is V2 plus. I can't see it, but it must be V2 plus, and it's been oxidized into V3 plus. So the half equation for that reaction, right, on the vanadium half equation, would be the one that you've put down. So it's vanadium 2 plus is going to go to vanadium 3 plus plus that electron. So that is being oxidized. But what happens now is the V3 plus, which you can see here, is now a reactant, right? It's a product of this little reaction here, but it doesn't stop there because it is now a reactant in this reaction here. Okay, because it's still got a less positive, right? This 0.77 here is still less positive than our 1.52 of manganate, which is in excess. Okay, so a subsequent sequential reaction happens. So the V3 plus, right, this V3 plus H2O, all right, is oxidized to VO2 plus, giving up an electron. But it doesn't even stop there because this reaction here, our E0 is still less positive than our manganate reaction, right? So this VO2 plus now becomes the reactant in a third sequential reaction. So it turns itself into VO2 1 plus. All right, so let's write that one out. So there's our reactant from here, VO2 plus. But you need another water there, plus H2O is going to go to our VO2 1 plus, VO2 1 plus, plus a couple of hydrogens, plus the electron. Okay, so now you sort of it only gives you one line here. Doesn't mean that you can't do your workings up here, but I think it's surprising they expect you to do that in one line. I know there's only one mark for it, but no, you have to combine these three reactants. So you can see that that V3 plus is going to cancel out with that one, and that VO2 plus is going to cancel out with that VO2 plus. So then we're going to add all our reactants together. So we've got V2 plus 2H2O. And that's going to go to our final product, VO2 1 plus, plus 3 electrons and 2 plus 3 electrons, and there's 2 hydrogens there. But we have to just check that's balanced. It's not balanced because we've got 4 hydrogens here. So let's turn that into 4 hydrogens, in which case our charge is balanced. We've got 2 plus on the left-hand side, and we've got 4, 5 minus 3 is 2 on the right-hand side. So there we have the final half equation there. Right, so I think the thing that you missed is these extra sequential reactions that happen with vanadium. The only time I've seen that sort of thing is with vanadium. So if you can sort of get your head around this question, then you're likely to be able to handle any of these sequential reactions that happen if you get an exam question on it. Hopefully that's helped, Aleph. Thank you.